Now, beginning with the today's session, it is CUDA profiling tool, that is NVProf, right? So profiling means that we can see the timing.
Just
Yeah,
yeah, just one doubt. Are you going to share these slides to us?
pardon.
Yeah, Vinod, I think
Are you going to?
yes,
Yeah,
Vinod, the slides are shared. You should have got the slides from the previous session already by mail.
yeah, yeah,
Please check your email. If not, I can share it to you offline.
yeah, right.
Sure. Thanks, Ravi.
Yeah. So, well, profiling means that we can see the timing of different types of operations which are taking place in our CUDA program, right? Like CUDA kernel or CUDA different CUDA API calls, all we can see. So, it was first of all, it was introduced by. Let me turn on my highlighter. Well, yeah. So CUDA 5 added a powerful tool to the CUDA toolkit with the name NVProf, that is NVIDIA Profiler. This is basically a command line profiler available for it's available for Linux, Windows as well as OS X, right? At first instance, from the command line profiler, we just get the idea that it is just a GUI less version of the graphical profiling features which are available in the NVIDIA Visual Profiler. That is the Visual Profiler provided by NVIDIA, and in Nsight Eclipse Edition. Well, NVProf, it has a much more functionalities than that. NVProf is the basically it is a very lightweight profiler that reaches where other tools can't reach, right? Now, we can use NVProf for quick checks, right? What are the capabilities of NVProf that we'll discuss in detail? So, what we can do, we can use to check if the CUDA application is running as it is expected to. Sometimes this is just a sanity check, that is the app running the kernels on the GPU at all. Now, also to check if our code is performing excessive memory copies. So by running application with NVProf, we can quickly see a summary of all the kernels and memory copies that it is using or that it is doing. So we can see the our kernel execution timing or profiling, and also the profiling of memory copies like D2H or H2D transfers or API calls. Now, how to use NVProf? It is very easy to use NVProf. First of all, we have to open the command prompt as the administrator. If we and then its syntax is NVProf, then command line options, then name of our CUDA application or CUDA executable file, and if there are any arguments to that particular file, command line arguments. So that is NVProf. If we do not specify any other option, just we mention the name of our executable file generated by NVCC, then it will start NVProf in the default or the summary mode. The summary mode is the default mode of the NVProf. Now, regarding the there is whenever we see the output of the NVProf, it will be prefixed with the process ID. Just like our program executable file, when NVProf will execute it in the operating system, a process ID will be attached by operating system to our executable file. So that process ID is prefixed in the output of the NVProf whenever we run it. So as I told you earlier that we can use the either we can run the NVProf in the command prompt, or we can also configure the NVProf in the edit plus. That I will just go through after the couple of slides. Now, what are the different modes? We were discussing about the different modes. Okay, let me show you just the sample output of the NVProf. So even if we have to, just like if I do it on command prompt, for example, we have a sample output, a sample program. The last time uh, we have seen the SAXPY program. So we have to run the command prompt in the administrator mode. I hope all of you are able to see the command prompt. We can go to the folder where our executable file is placed. Then simply we type nvprof and then name of our file, that is test1. We can see that there is an executable file test1.exe in this. So nvprof test1, right? So first of all, it will execute the program. For profiling, it has to execute the program. So this is the output of our program, right? And profiling starts from here. I hope all of you are able to see the output. Is it clearly visible?
Yes, Vikram, you can.
Yeah. So the process ID that is mentioned over here, 13188, right? This is again the output of our program only. So this process ID is prefixed in the profiler output, and we can see that we can see different timing details. It is showing like CUDA mem CPY H2D. We had different CUDA transfer commands in our program, like CUDA mem copy from host to device, CUDA mem copy from device to host, and name of our kernel, that is the SAXP kernel, right? So what are its timing? Average timing it took 79.106 milliseconds, minimum time and maximum time, right? So Rohit, as you have asked the question last time, what happened if we put the SAXP kernel or any kernel multiple times? So just like in the profiler, it is over showing over here. There is one call to the kernel, right? If we put the same kernel multiple times, of course there will be multiple calls, and that will be recorded by our NVProf profiler. By default,
Okay.
all the kernel will be executed on the default stream, and they will execute in the sequential manner only. That is the first call, then second call, and third call, and so on.
So sorry, Vikram, can you repeat the last line you said?
I said that
On a
let's say if I repeat this kernel multiple times in our program, we call this kernel multiple time. By default, if we do not mention any other stream, it will be loaded onto the default stream only, right?
Yes.
and
Yes.
then they will be executed sequentially in the order in which we have placed the commands.
Okay.
Yeah, yeah.
Okay.
And if we put the multiple calls, that will be put over, that will be appear over here, and when then we can see that what was the average time, what was the minimum time, and what was the maximum time, right? And this is the first call. It is mentioning GPU activities, and then timing percentage of total time, how much total percentage time it took, it has taken, and this is the exact timing, right? And second portion, it is showing the timing taken by the different API calls in the same format, like CUDA malloc or CUDA memcopy, and other different like CUDA free, CUDA launch kernel. These are the different API functions uh, which are called in the execution of our program. So, well, this was the one way to execute the NVProf in our command prompt. So edit plus, I will just we will go through once we will also configure the compiler. Then we will go through how to configure it into the edit plus. Now, continuing with the different modes of the NVProf. Right, NVProf default mode is the summary mode. Right. So NVProf presents an overview of the GPU kernels, as we have seen. Overview of the GPU kernels and memory copies in your application. So this summary groups all the calls to the same kernel together, presenting the total time and percentage of the total application time for each kernel that we have seen. So this is the sample output which we have just seen in our in the command prompt.
Hello.
Yes,
Can you please tell again this 10824 number? Last time 13118. What was that? I missed.
10824. Yeah,
824. Yeah.
yeah, yeah. This
So
is the
what is this number?
this is basically process ID. See,
Okay.
NVProf has to do the profiling, and it will of course
Okay.
execute over the code, and the process will be attached by the operating system, right?
Okay.
So this is
Okay.
that process ID. Fine.
Okay. Thanks.
Okay, okay. Now we coming to the second mode. Second mode, basically, I put these are two different modes: GPU trace mode, and API trace mode. These can be enabled individually, or these can be enabled in combination in NVProf, right? What if we get facilities in this mode? It shows the complete list of all kernel launches, right? Then it shows the memory copies, just like in the default mode. And if we do it in API trace mode, it shows all the CUDA API calls, right? So what is its syntax? Its syntax is NVProf. If we have to enable the GPU trace mode, the option is double hyphen print hyphen GPU hyphen trace. That is to get the output in print GPU trace mode, the name of our application, that is CUDA executable file, and if any arguments, right? Now we can see which kernel ran on the GPU as well as the grid dimensions. So it will also mention the grid dimensions of each kernel launch, right? It is very useful when you want to verify the your executable CUDA executable file on a multi GPU system, that whether it is running in the way as it is expected or not, right? So GPU trace mode and API trace mode, they can be enabled individually or at the same time. So as I discussed earlier, we can enable GPUI trace mode, GPU trace mode, as well as API trace mode in the Edit Plus that we will go through. Uh, More about this modes. GPU trace mode basically provides a timeline of all the activities on the GPU in the chronological order. Each kernel execution and memory copy or set instance is shown in the output. For each kernel or memory copy, detailed information such as kernel parameters we can see shared memory usage, we can see the memory transfer throughput. So it also will show a number in the scare brackets after the kernel name that I will just show you. It correlates to the kernel API that launched that kernel. Now coming to the API trace mode. Now API trace mode shows the timeline of all the CUDA runtime and driver API calls invoked on the host in the chronological order. And what is its syntax is nvprof and double hyphen print hyphen API hyphen trace. Rest is same CUDA application and then if any arguments. Now this is the GPU trace mode of our SAXP code. Probably it is not clearly visible. Let me zoom it out. Okay, but we execute it in the command prompt only. Again, using the same process, we open the command prompt in the administrator mode. Then we go to the folder in which our application is present. So we have file test1.exe, right? So nvprof, our mode is GPUI hyphen hyphen GPUI hyphen trace hyphen mode and name of our application that was test1. Probably there's some mistake in the exact spelling mistake. Let me see. Yeah, it is double hyphen print hyphen GPU hyphen trace. It's print basically. Print hyphen GPU hyphen trace. Right? So again, first of all, it will execute over kernel and then it will show the output in different, we can see different outputs. Columns are there: start time, duration, then grid size of every kernel. Then we can see that device name is the GeForce GT740M. What is the block size? So this is a grid size. Grid size, this one is the grid size 327681. So this was X. First, this is the X dimension, Y dimension, and Z dimension of our grid. So total number of blocks multiplied by all these three together, 32,768. Then block size, that is 1024x x dimension, y dimension, and z dimension. So all three multiplied together, 1024 threads in particular block. It is showing how many registers used, shared memory used, static shared memory, dynamic shared memory, and how much global memory transfer took place and throughput. So in the end also it is showing some details of the abbreviation used, like SSM is the static shared memory allocated per CUDA block, DSMEM, that is dynamic shared memory allocated per CUDA block. Then SRC memory type, the type of the source memory accessed by the memory operation or copy. Similarly, DST memory type, DST mem type, the type of the destination memory accessed by the memory operation or copy. So we get more detail in this GPUI trace mode. Similarly, we can invoke the API trace mode. Uh, just in place of GPU, we have to place the keyword API. So now the command is nvprof double hyphen print hyphen API hyphen trace, and name of our application test1. So we can see that now in this mode, it has shown the timing of different APIs only. It has not shown the now kernel timing. Different API functions which are maybe which are of CUDA runtime or which we have written in our program specifically. All those API calls, what are the timings taken, start time and duration, start time and duration, and name of the API. So this we get in the API trace mode. Well, we can enable both together, I suppose, as we have seen. Print hyphen API hyphen trace. Oh, sorry, print hyphen GPU hyphen trace. So now it is the combination of both. It will show the combination of both now. API calls details as well as our CUDA kernel call details. Profiling, it will be showing. So, right, it was our GPUI trace mode and the API trace mode. Now, next mode is the event / metric summary mode. Metric, as you know, that to calculate the different parameters of our metric, like throughput or bandwidth or timing, these are the different metrics of our CUDA application. So details of the metrics or events we can see in this summary event or metric summary mode. First of all, if we want to see list of all the available events on which we can make the query, to see list of all the available events on a particular NVIDIA GPU, we can use the command nvprof double hyphen query hyphen events, right? So it will show us the list of all the possible events. Now to see the list of all available metrics on a particular NVIDIA GPU, we can use the command nvprof double hyphen query hyphen metrics. Now nvprof is able to collect multiple events and metrics at the same time, right? Now when collecting multiple events or metrics, nvprof uses kernel replay. If we want to get the details of multiple events and multiple metrics, then the nvprof will have to it will have to execute the kernel multiple times. So that is called as the kernel replay, to execute each kernel multiple times as needed to collect the all the requested data, right? Now if a large number of events or metrics are requested, then large number of replays are required, resulting in a significant increase in the application execution time. So for example, over here we can see the what type of events are there, like nvprof, that is the command, double hyphen events under events. Now the events we are seeing here, wops underscore launched. How many wops are launched by the kernel? So this is the event. We can get its detail. A branch is another event. And double hyphen matrix, IPC is one of the matrix, like the instructions per cycle, and then name of the application. So this is the sample output. Probably it is not. If it is not clearly visible, I will again run it in the command prompt. So following the same procedure, I think I exited last time. Opening the command prompt as administrator. Going to the application folder. After this, first statement is like nvprof double hyphen query hyphen events. So it will show a large number of events which for which we can make the query. Uh, like one event we discussed, wops launched, how many threads were launched, and there are multiple events we can study by this nvprof. So whichever event is of our interest, we can get detail about that event, right? Like global memory load hit, how many times the global memory was loaded, and how many times global memory load was missed. And similarly for different memories, similarly for global memory store transactions, how many times the store transaction took place, or what was the timing of those events. So similarly for the shared load replay, shared memory, shared memory storage details, or shared memory load details. So all these event details we can see. And if we want to see the list of metrics available, then we can use the command nvprof double hyphen query hyphen metrics. Instead of events, we can query about metrics available. So different metrics we can see over here. In the beginning, just let me go to starting, where I have written the command. So it is a large number of metrics we can study. Yeah, this is the place we have started our command, and you can see that such a large number of metrics we can study. So device number is 0, and device name is the device. This model is GE4 GT740M. So different events like cache global, L1 cache, L1 cache global hit rate, L1 cache local hit rate, or SM efficiency. IPC, as we will be using in this command, instructions executed per cycle. Similarly, the metrics related to the throughput we can study. So these are the a lot of metrics we can study, and lot of events we can study in this events metric mode. And the command we can see, this is the sample command to study events wops underscore launched and metrics, let's say IPC on test 1. If I type this command over here, so this is the output we have received. This is the program output. then the event process ID number, right? So we can see that event name regarding the branch, it has given us the output that the branch, there was no event found on that device with this name. So if we talk about event name wops underscore launched, so minimum wops launched, maximum wops launched, and because our kernel was executed only once, so there is only all these three are same. So these are total number of wops which were launched. And second, we have inquired about the metric IPC. So it has given the output of different like 0.28, 0.28533, again minimum, maximum, and average IPC.
Yeah, hello, Vikram.
Yeah.
Sorry, so what are the metrics that we should be interested in to understand the GPU utilization?
Yeah, we should be mostly using the throughput that is measured in the gigaflops per floating point operations per second. We may be interested in the bandwidth, memory bandwidth, right? Then we may be interested in the timing, metrics. So these are the main metrics that also we'll be studying in some another presentation. Throughput, then timing, and then bandwidth, right?
So, okay, with respect to the compute, any other
Yeah.
metrics?
Other metrics, there are many other metrics, but these three metrics are mainly we will be studying. Well, it depends upon your requirements. You will have to, you can see whichever metrics of your interest, by the way. And if we talk about throughput also, we can get the throughput related to L2 cache over here, for example. So throughput related to different type of memories, throughput related to global memory, or throughput related to shared memory, or what is utilization of L2 memory over here, for example. So there are large number of metrics you can see over here. But mainly, if we talk about our computation of our application, we'll be studying about throughput and bandwidth and timing. These three mainly we'll be studying, and how to calculate it. So there again, it can be calculated in two ways. Either we can calculate it through our program, we can write the program to calculate these metrics in our program only, or we can get these values through the NVProf. So we have both of these techniques, right?
So Vikram?
Yeah.
Yeah. So Vikram, so the ones that you just mentioned now, typically throughput and all of that,
Yeah.
they are actually on the memory fetch, read, write, and that kind of operations,
Yeah.
right?
Yeah.
Is there something that tells about the how much of the GPU is getting utilized? Like what I'm trying to say is, let's say you're on a Windows machine, you can just look at CPU and it shows, right? CPU utilization, the graph keeps going up and down.
Similarly, we can get for GPU also.
Yeah. So what is that metric for
Let,
GPU?
let me show you. We can just like we get the in our task manager, we can see the CPU utilization. Here it is showing for GPU utilization also. For example, here it is CPU utilization, and here at this is GPU NVIDIA GE4 GT 7M. So we are able to see its you can say GPU utilization. This dedicated memory, that is the global memory, is 1 GB. If you are able to see it, I think the font is very small. This 1 GB, and this shared memory 4 GB. So this is one way.
Yes, do you
Yeah.
have a profiler, some kind of argument that can help us
Some
get
kind of
this?
metric. Yeah.
For this utilization. Okay.
Yes.
Yes.
Fine. GPU utilization. Yeah, there are these utilization, but probably I didn't go through these. But these are you can see that they are these like system utilization, right?
That's on the memory.
Yeah. Similarly,
Memory.
DRAM utilization. This is for texture memory utilization. Probably, are you able to see this?
Yes, these are all on the memory. We understand.
Yeah.
We just were wondering if
Okay, so
the same
GP,
diagram that you showed, is there something for GPU? You
GPU.
can let us
Maybe,
know once you
maybe,
get that answer. Yeah.
maybe the number of CUDA cores that are utilized.
Yeah, yeah. Of course, we will definitely we'll have to trace these the whichever these metrics are of our interest, that like issue or slot utilization is there. So anyway, I will go through this. Probably I have not gone through these particular metric you are talking about, right? So whenever
Sure. So please let us know once you get information.
yeah, yeah, I will discuss if I get this information, right?
So also if there is like say warp divergence, or if the kernel is waiting for the data, so in such cases there will be idle cores, right? So these kind of information will be helpful to know how good our
Okay,
individual kernels are.
okay, okay. You just put one thing. You put your this query in chat also. So even if I may get later more details, then we can discuss about it, right? So, so should I go further?
Sure, Vikram. Thank you.
Yeah. So now coming to our next mode, that is event metric trace mode, right? So this is again related to events and metric only, and one more part, that is trace, has been added. So in event metric trace mode, the event and metric values are shown for each kernel execution, for kernel specific execution, right? Now by default, event and matrix values are aggregated across all the units in the GPU, right? For example, by default, multiprocessor specific events are aggregated across all the multiprocessors on the GPU. For example, this GT740, it has two multiprocessors. So in this mode, it will, whatever output it shows, it will show aggregate of both multiprocessors. But we can turn this mode off. If we turn the mode aggregated mode off, then values of each multiprocessing will be shown separately. Multiprocessor 1, multiprocessor 2, right? For example, if we want to see the event wops underscore launched for all the multiprocessors, right? Then we can use this command nvprof. We have to turn off the aggregate mode. So aggregate mode will show it separately for different multiprocessors, and then the events which we want to query, events double hyphen events, and then wops launch, that is the name of our event, and mode is print GPU trace mode. So we can see that it is basically event metric mode is a combination of event matrix previous mode and the trace mode. It is the combination of these two modes and the name of our application, right? Now, same way as it is aggregate mode is also applied to the matrix. Just like it is applied to the events, it is applied to the matrix also. But however, some of the metrics are only available in the aggregate mode and some are only available in the non-aggregate mode. So, for example, this is our command over here. nvprof, this aggregate mode of events we want to study is aggregate mode is off. Event we are studying wops underscore launch and print GPUI trace mode and name of our application. So we can see the output is device name, then context stream number 7, context 1, then name of the kernel, this is the name of the kernel, and type of the arguments, then warps launched by first multiprocessor are this much and this many, and warps launched by second multiprocessors are this many, like 5,24,896. So in this way we can get the details of our different events in the trace mode, in the aggregate mode, or in the non-aggregate mode. The sample output we have seen. So these are the different modes of NVProf. So we can see that now for the functionality of NVProf, uh, so in this way we can use it to profile our CUDA kernels running on NVIDIA GPUs. No matter in which language they are written, they may be written in any language, but as long as they are launched using the CUDA runtime API or driver API. So it means that we can use the NVProf to profile uh, other GPU based programs, means in other languages such as OpenAC. This is the directive based programs which do not have any explicit kernels. We can use for OpenAC based program also. And the PTX programs, these are basically the NVCC can generate the PTX files which can be embedded into other platforms. So PTX files can also be profiled using NVProf, or we can profile the programs either we have written in the Python or Fortran in different supported languages.
Hello.
Yeah.
You're hearing some lot of background noise. Is it anyone? Can you please mute from your side?
Pardon? Is there sound coming?
Hearing a lot of background noise from I don't know who has done.
Right. Okay. So, well, it is very important if we are implementing our program in OpenAC or in other languages, because it is not obvious. Because we see that C++ is the native language, but other languages which are derived one, it will be very useful tool when we get the details of our different different statements, timings we can get, or profiling details we can get through NVProf. So this is also a great example of the sanity check ability to of a lightweight command like line. It's a command line GPU profiler. So NVProf can also generate profiling metrics, or it can also export its results for analysis in the NVIDIA Visual Profiler. So it can generate the intermediate data that we can import into the Visual Profiler, and detailed analysis we can get into the Visual Profiler. Now another use of NVProf is for the remote profiling. We can do the remote profiling through this. Because if we are working on a remote system, that is, if you sometimes the system that you are deploying on your application is not your own desktop system. For example, if you are using the GPU cluster, or if you are using the a cloud system such as the Amazon or EC2, or it means that if you only have terminal access to the machine, you don't have any full access, you have only terminal access to that machine, then you can get connect to the remote machine and run your application under the NVProf for profiling. So what option we have to use for remote profiling? We have to use the option this double hyphen output hyphen profile command line option we have to use. In this way, you can output a data file for later import into the either NVProf or NVIDIA Visual Profile. It will again, as we have discussed earlier, it will generate the output profile that can be imported into our Visual Profiler. Visual Profiler is at our local system, but we have generated the intermediate data from the remote system. So that is, you can capture a profile on the remote machine and then visualize and analyze the results on your desktop in the Visual Profiler. As we have discussed earlier, this is another option, analysis underscore matrix. It is used to capture all of the GPU metrics that the Visual Profiler needs for guided analysis mode. So, by importing the data from NVProf, Visual Profiler can be used to determine the bottleneck of our kernel. Right. So this was all about NVProf. Now, as we discussed earlier, I will go through the configuring the different
Hello.
tools. Yeah.
The noise is still coming actually in
But
the background.
I'm not able to hear any noise, by the way. I don't know
Uh,
what type of noise.
Excuse me.
Yeah.
I have a question regarding the NV Pro.
Yeah, please.
So, as far as I know, NV Pro is somehow deprecated for new GPU, right?
Pardon? GPU?
As far as I know, this tool is deprecated.
Okay.
For new GPU, it is not supported, right?
Yeah,
Do we
yeah.
have any plan to present anything regarding inside?
You mean to say if the GPU is not supported by NVProf, then what we should do? Is this your question?
Yeah, I think there is another one called inside, right? Do we have any plan to show anything about it?
Well, if I think NVProf supports all the GPUs because
No, the
okay.
latest one, just like 5000, it's not supported. The latest 203 architecture is not supported.
Well, then we can use any other tool. There are other tools available also, like NVPP is
Yeah,
available.
that's why I wonder, do we have any plan to show inside system or inside compute?
Yeah, we will discuss about using Visual Profiler. We can use Visual Profiler if this is not supported. Then we can use Visual Profiler. That will be going through in some. I think in next week we'll be going through Visual Profiler.
Sorry, both
No,
NV and
inside is not a visual profile. It have a command line too.
Yeah. Today we are discussing only about NVProf.
So NVProf and Visual Profiler both are deprecated for your GPUs. More about Insight Compute and Insight Systems.
Yeah, Nsight. Yeah, that we will discuss next week about Nsight and all these. There are different tools, the Visual Profiler tools, right? So basically, this is we can use combination of these two also, like NVProf, as we discussed here. It can generate the intermediate or matrix data that we can import into Visual Profiler, or it can be used directly also. So Visual Profiler and Nsight, that will be going through it in the next week only. So fine. Any other query regarding this NVProf, please?
Sorry, I have one question. Maybe I missed it. I don't know. So how do we profile the code? like now, what are the hooks we have to put in the code, and what is that we have to take care while coding? And if at all we were coding from other than the .cu file, maybe we are doing a kernel launch from the C code or a CPP code.
Yeah.
So, and yeah, how do we understand? Like, how do we profile it accurately?
Well, basically accurate. This is our once we that is basically the steps of development. Once we write our code at the first step and we see profiling, we do the profiling and we see that which of our part is making any problem, right? Which part of our code is taking too much time. Then we can concentrate on that part. So basically in this NVProf we can see different sections of our code, what timing they are taking. So but optimization part that we have to take care of. We do optimize and then again we can study that what advantage we have got by doing our optimization. So this is the, I think that is the process of development only. And regarding the hooks, all the there are so many options available in NVProp. Means you can see detail of particular your particular related event or metric, uh, or particular statements or particular API calls or particular functions or kernel calls. Details you can get from that. Details will be provided by NVProp. So I think we need not to do anything in our code for this. All the thing is handled by NVProf for that, by NVProf only. If we are doing
I mean, I mean, like, no, like we have a piece of code where it's a mix of both host code and the GPU code, right?
Yeah.
So if at all we want to profile only the GPU code, like what are the CUDA APIs that we need to use?
It will see this NVProf will profile only the GPU code only. It will not profile the host code. NVProf will pick up the GPU code only. That will be profiled by NVProf, right? The host code or host APIs, they I think they will not be profiled by NVProf, right?
Yeah, okay.
So going through the our previous slides, previous presentations we were going through in our last session. It is also basically it includes how to configure it into Edit Plus or how to compile our code. Yeah, we were at this place in the last previous session. So I hope CUDA indexing is clear. That is how the thread index is being created. There, for example, in this diagram, we can see that there are different blocks, and each block is having multiple threads. And how we generate the unique index of a particular thread. For example, over here, thread number 3 of block number 2. So this is the calculation we have used, that block IDX, that is the block index multiplied by number of threads per block plus the thread local thread index. That will give us the unique index, right? For example, here block index, that is 2, right? And so block index is 2 that we have put over here. Then number of threads in the block plus thread index, that is 3 that we have put. And finally we get the overall index of our thread. So this was in our device kernel code in the SAXPY kernel. Now compiling, I think it is it's basic commands again in the command line option, that this we have not discussed. how to compile it in the command line. NVCC, that is the our compiler, right? And -o is the output file, and then it will file name without extension, that is its syntax to use NVCC, and then file name with extension. So this is an example code statement. I will show you just how we compile the program on the command prompt. Using the same process, that opening the command prompt in the administrator mode, we have to go to the folder in which our file is present. So our code is this test1.pu, that is our code we have studied in the previous session. SAXPY code. This is the CUDA code to perform the SAXPY operation of n elements. So name of our file is test1.cu. So this is the syntax to compile the code. NVCC -o. Test1 is the name of the output file, and this is our source file. So it is compiling the code. Right. So the code compilation is complete. Right. So this is how we do it in the command prompt. Now we can use the tool Edit Plus to configure different this commands like NVCC compiler or code execution or nvprof. So basically, Edit Plus it is a feature-rich text editor for Windows. It can be configured for different. We can configure anything into this. We can configure CUDA code compilation. We can compile it for execution of our code. We can also compile. We can also configure the for it code profiling. Right. So what are the initial steps we have to do for Edit Plus? Of course, you can download it and use it. First of all, again, just like command prompt, we open the command prompt into the administrator mode. Similarly, Edit Plus also we should open in the administrator mode. Basically, administrator mode